Yes. So some of them with solving will give you all of them to begin with. Now all the ones we'll work with will give you enough to get it down to a quadratic. Then we can use synthetic division to solve from there. Now the first ones we're going to look at on the review sheet are problems 1, 2, and 3. We can go on and look at all three. Problem number 1, what is the degree of this polynomial? What would the degree of this be? It is 8.
You have another one.
And the leading coefficient would be negative 27. The degree is the exponent, or the biggest exponent attached to a variable. Leading coefficient is the number in front of the variable with the biggest exponent. So in this case, it would be negative 27. What would the degree for number 2 be? Leading coefficient is? Well, number 3. The degree is 7. Leading coefficient is negative 27. And that's it. Now it is coincidental that the leading coefficient for the first and third one are the same. Any other questions about finding the degree or leading coefficient? Questions on 4 through 7. Evaluate the polynomial for the given value. Which one do we want to look at? 4. When we evaluate this, all we're doing is plugging in negative 4 in for every x. Now at this point here, we can plug this all into the calculator. If we type it all in, we get negative 854. That's it. Questions on this here? Is there another one of these that we want to see? Which one? We'll do one more. So which one do you want to see? So for 7, we're replacing all the values with negative 12. So we'd have 5 times negative 12 cubed minus 3 times negative 12 squared plus 2 times negative 12 plus 4. We're replacing every x with negative 12. And then we can type it in. 5 times negative 12 to the third minus 3 times negative 12 squared plus 2 times negative 12 plus 4. And if we type it all in to the calculator, it'll tell us it is negative 9,092. And that's it. Any other questions on 1 through 7? Eight, 9, and 10. Determine if the following function is a polynomial. So to determine if they're polynomials, they've got to not have any of the following traits. They have to have these. It is not. Exponents aren't negative. Exponents aren't fractions. And these are really attached to variables. And there can't be an exponent that is a variable anywhere. variables aren't inside radicals, and variables are not multiplied together. Then we can also not have variables in the bottom of a fraction. Because, I mean, you could write them right in there. Because these here don't have much of an answer or part to them. I mean, you could write them there if you want. All right, we get these down. So looking at these here, number 9, is it, or not number 9, number 8, is it a polynomial function? Number 8, let's start with 8. So are the exponents negative? So this is no, because the exponents can't be negative, they cannot be fractional. We can't have a variable in the exponent. We cannot have a variable inside of a radical, bottom of a fraction, or two different variables multiplied together. Let's look at 9. Are any of the exponents negative? No, and it's really negative attached to a variable. Are any of the exponents fractional? No. And both of those are really attached to the variables, but we're not going to worry about that at this point because that's only where exponents are going to attach for this test here. I mean, there's not going to be a number with an exponent. We won't have 4 squared or 4 to the 1/2. Are there variables in an exponent? No. Is there a variable inside of a radical? Well, there's no radicals at all. Variable in the bottom of a fraction? No, there's no fractions. Are there two different variables being multiplied together? So is this a polynomial function? Yep. Yeah, for these here, it's either yes or no. 10. Yes. Is 10 a polynomial function? No. And specifically, it's got to attach to the x, because if it had been 4 to the 1/2, technically it'd be fine, because that's just a square root of 4. But this is no. Now, our problems 8 through 10 and 1 through 3 are really going to be put together, because on the test, it's going to ask you if is the following polynomial a function, is the following function a polynomial? If yes, state degree and leading coefficient. If not, just say no. So any other questions on 8 through 10? Questions on 11 or 12? We're going to look at 13 in a minute, but let's look at 11 and 12 first. 11. Since we're adding, we can just drop the parentheses. So we'd have 3x squared plus 4x minus 1. And we'd have our negative 2x squared minus 3x plus 2. I mean, we could put plus negative 2x squared or minus 2x squared are the same thing. Now at this point here, we need to combine like terms. I always start with the variable with the biggest exponent, which in our case is x squared. So we have 3x squared minus 2x squared. 3 minus 2 is, it's just x squared. 4x minus 3x is plus x, because our 4 minus 3 is 1, so we just have x. And lastly, negative 1 plus 2 is plus 1. So we have x squared plus x plus 1. Questions on this here? Any other questions on 11 or 12? Questions on 13 or 14? Is there, do we want to look at 13 or 14?
Yeah, can we just look at
We can look at 13. Now with 13, the first set of parentheses, the one that does not have this sign in front of it, we're going to just drop the parentheses. Since there's no sign in front of it, we can just drop the parentheses because really we're just multiplying through by positive 1, and multiplying by positive 1 does not change a thing. Now the other set of parentheses has the negative sign in front of it, and we have to distribute it through that entire set of parentheses. So our positive 2x to the fourth is now negative, yes. Our positive 3x cubed is now negative 3x cubed. Our negative x squared is going to become positive x squared. Our positive x is going to become negative. And our negative 4 is going to become 4. Now we combine like terms. And again, I try to keep it in standard form. So the x with the biggest exponent is our x to the fourth. So our 7x to the fourth minus 2x to the fourth is 5x to the fourth. Our next one would be cubed. Negative 9x cubed minus 3x cubed is negative 12x cubed. Our next one is going to be squared. Negative 4x squared plus x squared is negative 3x squared. 5x minus x is plus 4x. And lastly, 6 plus 4 is plus 10. So really for this here, we just distributed the negative, combine like terms. When adding two polynomial functions, we just combine like terms. Which one? Now the first one, again, no sign in front of the parentheses, so we can just go on and drop it. Now the negative in front of our other has to be distributed through. So our positive 2x to the fourth becomes negative. Our positive 6x cubed becomes negative. Our positive 2x becomes negative. And our negative 9 becomes positive. We're just changing the signs with that negative. Questions on this here? Now I always start off with the variable with the biggest exponent. So that's our x to the fourth. 11x to the fourth minus 2x to the fourth is 9x to the fourth. Well, the next one would be cubics, our third power. Well, the only one with the third power is 6, so we have negative 6x cubed. Then we would go to our x squared term. Well, the only one with an x squared is negative 9x squared. X, we do have two of them, 3x and negative 2x. 3x minus 2x is plus x, and 11 plus 9 is plus 20. So if there wasn't any other like terms except for the 1, we just put it in its place. There's nothing to combine it with. Questions on 1 through 14? We good with 1 through 14? Questions on 15 or 16? Multiply through. Which one do we want to see? So we distribute through. We'll first do 6x cubed times 2x cubed. So our 6 times 2 is 12. X to the third times x squared would indeed be x to the fifth, because we add the exponents when we multiply like bases. Now the next one, 6x to the third times negative 27x. We do 6 times negative 27, which is negative 162. And our x to the third times x would be x to the fourth. And lastly, 6x to the third times 4 is 24x cubed. And that's it. Questions on 15? Questions on 16 or 17? Is there one of those that you want to see worked? We good with 16 and 17? Questions on 18 or 19? Whenever we multiply three polynomial expressions together, we multiply two of them together first, simplify and multiply the third. So the first thing we're going to do is multiply these two here together. So we'll distribute the x first. X times 3x is 3x squared. X times our 1 is plus x. Then we'll do the same thing with negative 2. Negative 2 times our 3x is negative 6x. Negative 2 times 1 is negative 2. And then we'll bring down our 4x minus 3. At this point here, it's going to be helpful to combine like terms. Our x minus 6x is negative 5x. Questions on how we got to this point here? Now, our next part is going to be to distribute here. 3x squared times 4x. 3 times 4 is 12. X squared times x is x to the third, x cubed. 3x squared times negative 3 is negative 9, x squared. We'll do the same thing with negative 5x. We'll distribute it. Negative 5x times 4x is negative 20x squared. And negative 5x times negative 3 plus 15x. Then lastly, we'll distribute the negative 2. Negative 2 times 4x is negative 8x. And negative 2 times negative 3 is lastly, we're going to combine like terms. 12x cubed does not have any like terms. Funny enough how this one worked out, all of our like terms that we do have are next to each other, already by each other. Negative 9x squared minus 20x squared is negative 29x squared. 15x minus 8x is plus 7x. And our 6 does not have any like terms, so it's just plus 6. Questions on any of this here? We good with 15 through 19, multiplication? Yes? Let's go to division. Let's go with dividing. Well, questions on 20, 21, or 22 are one of those that we want to see worked. 20. So we can do this by long division or synthetic division. I have a feeling you all want to do this by synthetic. First thing we need to do is take what we're dividing this by, our x minus 5, set it equal to 0, and solve for x. So we can add 5 to both sides, telling us x is equal to 5. The number that goes in the cubby is the number, or just what we got that x equal to. The numbers for that constant, so just be 5. Numbers going across the top are our coefficients and constant. So 1 would be for x to the third, and then negative 10, 20, and 26. We bring the first number down. Questions on how we set this up? The next part is going to be multiplying. Our 5 times 1 is 5. Negative 10 plus 5 is negative 5. 5 times negative 5 is negative 25. 20 plus negative 25 is negative 5. 5 times negative 5 is negative 25. And lastly, 26 plus negative 25 is 1. Questions on any of this here? Questions on anything we've done so far? Now we do need to plug our variables back in. Now, the last number, the number we put in the box, is the remainder. The number next to it is our term without x. The term in front of it is our term with x. The term in front of it is our term with x squared. So our final answer for this here is x squared minus 5x minus 5 plus our remainder, since we do have one other than 0, which is 1, so it'd be 1 over what we divided this by, so 1 over x minus 5. Questions on 20? We feel good with 20? Yes? Questions on 21 or 22? Okay. 22. So we can do it by synthetic. So the first thing we would do is get x by itself. So we would add 1 to both sides, telling us x is equal to 1. Questions on how we got x by itself and how we got the number in the cubbyhole? We good with all this so far? Yes? What would the numbers going across the top be? Bring the first number down. Multiply. 1 times 7 is? Negative 10 plus 7 is? Negative 3. 1 times negative 3? Negative 3. 3 plus negative 3 is 0. 1 times 0? 3 plus 0. 1 times 3? Negative 3 plus 3. We don't have any other numbers, so we're going to box it. And the last number is our remainder. The number in front of it is our term without x. The number in front of it is our term with x. Number in front of it is term with x squared. Number in front of it is our term with x cubed. So our answer is 7x cubed minus 3x squared plus 3. Because that means 0x is just 0. We don't need it. Since the remainder is 0, we don't need it either. Because they're both 0. We only needed them plugged in as 0 for us to actually do the division. We don't need them in our answer. Questions on this here? Questions on any of this so far? We're ready for the next one. Do we want to do this by synthetic or long division? Synthetic, because it is, we can do this with synthetic division. You do not. There is one on the test that requires, like this, that requires you to do by synthetic division, but that is a bonus question. So all the rest of them, there is one of them like this on the test, but it does not require you to do it by synthetic. You can do it by synthetic or long division. Now this here with synthetic division, we're not getting x by itself, we're getting the x squared term. So the first thing we would do is add 2 to both sides, telling us x squared plus 4x is equal to 2. Then we would minus 4x, telling us x squared is equal to negative 4x plus 2. Because it's an x squared, we have 2 numbers now. Instead of 1, we have 2 lines. Questions on how we set this up? Numbers in the cubby. One of them is going to be the 2. The other one is going to be the number in front of x, which is negative 4. So we do have 2 separate numbers. We have negative 4 and 2. If you need to put a line or something between them to space them out, or just have them spaced apart, we have these here. Numbers going across the top would be 2, negative 4, and 2. The first number we bring all the way down to the bottom. Second number goes down 1. Questions on this so far? Everything will be multiplied by the bottom number. So the first thing we're going to do is negative 4 times 2. Negative 4 times 2 is negative 8. It goes above the bottom line. Then we also do our second number, our 2, times this 2, which is 4, and it goes above the top line. Questions on this here? Next thing we're going to do is add. Straight down, negative 8 plus 8 is, negative 5 plus 4 is negative 1. Questions on this here? Now we're going to multiply the negative 4 by 0. Well, negative 4 times 0 is 0. Then we're going to multiply our 2 by the 0. 2 times 0 is 0. And again, our constant number, the 2, is going to go across that top line. The negative 4 is going to be the next line. Now again, we add. Negative 1 plus 0 is negative 1. Negative 4 plus 0 is negative 4. Questions? You're good. We ready for the next one? Negative 4 times negative 1 is 4. 2 times negative 1 is negative 2. And then we add negative 4 plus 4 is 0. 2 plus negative 2 is 0. Yes? Do we have any other numbers? Well, no, we're done, because anything we'd multiply the first one with, the negative 4's multiplication would go here, the 2's would go here, but I don't have anything up here to add with it, so we're done with doing the steps. Okay? Now, the one thing I would do at this point is bring the last 0 down so that we all have it all on the same line. Now, I'm going to go back a slide or two. For this synthetic division, how many numbers did we have in the box? 1. How many numbers did we have for our remainder? 1. Here, numbers in the cubby were 1. The numbers or values we had for the remainder was 1. How many do we have in the cubby now? So how many should we have for the remainder? 2. So these last 2 here are the remainder. Now inside the remainder, the farthest to the right is the constant. The one next to it is our term with x. Now for this here, they're both 0, so it makes no difference. Outside, the first number, our negative 1, is our term without x. 0 is our term with x. 2 is our term with x squared. So what we're left with is 2x squared minus 1. Since the remainder is 0 for both the x and the constant term, we don't have to list it. Questions on this here? We want to do one more of these. Yes?
Are you finishing this?
No. Let's look at another one, and I think y'all would prefer doing these by synthetic than long division. We can. This one here, we can do this with long division and synthetic division. I just want to change that from positive to negative, or from negative to positive x cubed. Now, with this here, changing it from negative to positive means that the answer we'll get will not match the review sheet, as obviously we're changing it. Now, the first step in doing long division is canceling out this 3x to the 4th. So we need to see what we need to multiply our x squared by to get 3x to the 4th. Well, we know we'll need the 3 and an x squared. Because when we do 3x squared times x, we'll have 3, and our x squared times x squared is x to the 4th. So we get them to be the same so that they will cancel out. Now we do have to continue distributing through. 3x squared times negative x is negative 3x cubed, and 3x squared times 3 would be plus 9x squared. Questions on this here? Now at this point here, we will subtract 3x to the 4th minus 3x to the 4th is 0. X cubed minus negative 3x cubed. Well, our negative and negative would make a plus. An x cubed plus 3x cubed is 4x cubed. 8x squared minus 9x squared is negative x squared. And then we bring our next term down. and we repeat the process. This time we're trying to see what times x squared gives us 4x cubed. Well, we need to turn 1 into 4, so we need to multiply it by a positive 4. X to x cubed means we'll also need an x. Questions on how we got the next term of 4x? Now at this point here, we're going to multiply again. We're going to do 4x times our x squared minus x plus 3. 4x times x squared is 4x cubed. 4x times negative x is negative 4x. And our 4x times 3 would be plus 12x. And again, we're going to subtract. 4x cubed minus 4x cubed is 0. Negative x squared minus negative 4x squared. Well, again, the negative and negative make a plus. Negative x plus 4x squared is 3x squared. 5x minus 12x is negative 7x. And then lastly, we'll bring down the plus 3. We're going to do this one more time. And this time here, we need to see what times x squared gives us 3x squared. That would be plus 3. So we're going to do 3 times our x squared minus x plus 3. And when we distribute the 3, 3 times x squared is 3x squared. 3 times negative x is negative 3x. And 3 times 3 is plus 9. And again, we're going to subtract. 3x squared minus 3x squared is 0. Negative 7x squared minus negative 3. The negative and negative make a plus. Negative 7x plus 3x is negative 4x. And our 3 minus 9 is negative 6. We don't have any other terms to bring down. We have 2 left. So this is our remainder. And we would add it back. So our negative 4x minus 6 over our x squared minus x plus 3. And that there would be the final answer. Questions on this here? Questions on anything we've done so far? Do we want to see this one in synthetic division also? If not, that's fine. We good with this here? Yes. Because again, we can do this with synthetic division or long division either way, because on the test, this one here, there will be one like this where we have a quadratic we're dividing the other one by, and you have a choice to do it by synthetic or long division. The bonus question, you have to do it by synthetic. So it's up to you on those there. We'll finish this tomorrow.